Welcome to this video. Here we will learn about basic programming on CNC lathe and CNC mill. For this we have to explain three main things: the axis, the buttons functionalities, and the compensation of the tool and the work piece 0. So let's begin. In this photo you can see in the screen it represents a compensation diagram. This shows us the different distances from some points that the machine have or should have. In this case, the diagram represents a turn. As you can notice, there is a black point in the choke of the turn. This is the machine 0 and is determined automatically by the machine. The other colors represents each a point measured from the machine 0. The point A is known as tool reference and is also determined by the machine. It is put on the pincers that grabs the tool. You can see it over there is the red point. The blue point, the B, is a new tool reference, which now includes the large of the tool we are using, because we want to be based on the point of the tool. Last but not least, there is the workpiece 0, and it's represented by the green point C down there, and it will be the base in which we will do all the work. Now let's talk a bit about the buttons of the machines. This is a turn CNC computer. The turn have many tools that help it to do a better work, like for example a PLC hardware, that is the screen, which controls the refrigerant, the speeds, and even the machine 0. Some of the CNC computer buttons are the blue ones, which you can see, but they are in the upper right part of the screen. These are used to command any kind of function. Those are the most common buttons to use. Under the blue buttons there are the numbers, which are necessary to specify any spec that the turn would need. Then the speed and the steps are determined by the two knobs in the inferior part of the computer. Between both knobs there are the buttons that control the speed and the spindle of the lathe. The buttons next to the knob and in the middle are used to control some of the mechanical parts of the robot, like the door, the choke, the hooks, etc. The last group of buttons align in which are helpful when moving the robot in Z and in X, in the XY axis. Well, let's remember that the lathe have just two axes. The Z-axis, which move horizontally, changing the part length characteristics, and it is limited by the large of the part, from the choke of the machine to the part 0. And the X-axis changes the part in a revolving way, cutting it as it rotates. It's limited only by the radius of the part. You can see in the image in the screen how does this axis is distributed. Talking about the mill, it too have some parts that help it a lot to do their job. For example, it have a carousel of 12 tools available, a source of air pressure, and a press. Well, first of all, sorry about the HD by DO, the high distortion, which causes that you can see well what buttons are, so sorry, but I'll still try. The gray cross with the green center is the control, and it helps us to move manually the robot on its three axes, X, Y, and Z. Just next to it are the spindle and feed speed controls. The red square backwards, the control help us to verify how does a part will be altered using our commands. The three color buttons in the lower right part are the operator buttons, used to stop, pause, and run the machine. In the lower center, the two big gray squares are the general machine information. And finally, on the left side, which you can see, are some numbers that control the mechanical characteristics of the robots, like the door, the air pressure, and the valve. Now, let's remember that the axes of the mill are the X, the Y, and the Z, as you can see in the image. The first two are represented as moving the plate on the mill machine, in which the part is collocated. The X moves from left to right, and the Y axis moves forward and backward. The Z axis is on the tool, which as rotating moves up and down. By clicking main menu and manuals, now you can determine the part 0 of the turn. With this, you can move the turn in the X and Z axis. Remember, use the knobs to determine the steps and the speed of the movement. To correctly determine your part 0, it is recommended to turn on the spindle. So, turn on the spindle. It's important to remember to put the spindle rotation in the contrary way as the tool blade. Remember the ice cream. After this, move the piece until the touching part in the plane face off of the cylinder. Something very important that I forgot to tell is that you must measure your part before anything else, by length and by radius, because those will determine your part 0. Now you have to wait and be pretty careful to touch the cylinder part and to hear that the tool already touched it. After this, you go to Medición, then Z. Put the length of the part, click on Cargar Eje Z. As you can see, you have to put the length of the part, not the radius. Once done this, you click Enter. Then repeat this for the X-axis, looking to touch the cylindrical part of the piece. You click Medición X and you put the radius of the part. After this, you click on Cargar Eje X. You click Enter. And remember to turn off the spindle. After this, you click Enter again and you go to Main Menu. You go to Tablas, Orígenes. You select one of the options. You click on Modificar and change the Z value to the length of the part. Then you click Enter. And now your part 0 is completely saved in the computer. Now you have declared your part 0. Now let's talk about the mill. To declare the tool compensation, you first need to click on Tool. After this, on Setup Tool Wizard. This program will tell us whatever we need to do, and it would ask you two questions: the height reference and the tool reference. If you got both, you click that you got both. After this, you click Already Inside. Then you have to move the mill to touch your part in the upper face with the tool using the spindle, and save your point. After this, release the part. Now let's start about declaring the part 0 in your mill. First, you will need to move your mill to touch each face of the part. one in the x-axis, one in the y-axis, and one in the z-axis. Just touch it, and when it already touched, you just stop. You have to write down those numbers that you are recollecting, because those will be needed then to declare the part 0. Remember something important: talking about the both side faces, the x and the y faces, you will need to take out the radius of the tool. You will see it after this.
Set up, coordinate systems, set up again, and then you change these numbers for numbers you calculated. In the case of y and x, you need to take out the radius of the tool, so that your part 0 would be the part that you want, because it is based in the center of the tool. Se movió esto.
He was